In this lecture, we're going to talk about equations and inequalities involving absolute value. In order to solve equations using absolute value, we want to do the following. First, isolate the absolute value. That is, get the absolute value by itself. Then, remove the absolute value by separating the problem into two equations. For example, if you have the absolute value of u equals a, then we would split that into two equations, u equals positive a or u equals negative a. So let's do an example where we solve an absolute value equation. We have the absolute value of 3x minus 1 minus 2 is equal to 0. The first thing we want to do is get the absolute value by itself. So we add 2 to both sides of the equation, and that gives us the absolute value of 3x minus 1 is equal to 2. Now that we have the absolute value by itself, the next step is to remove the absolute value bars by splitting the problem into two problems. So that'll give us 3x minus 1 equals 2, or 3x minus 1 equals negative 2. We'll start by solving the 3x minus 1 equals positive 2. We add 1 to both sides of the equation, and that gives us 3x equals 3. To get x by itself, we'll divide both sides by 3, giving us x equals 1. And now we'll go through and solve the 3x minus 1 equals negative 2 equation. We add 1 to both sides, which gives us 3x equals negative 1. Divide both sides by 3 to solve for x, and we get x equals negative 1/3. Let's look at another example. This time we have the absolute value of x squared plus x is equal to 12. Since the absolute value is already isolated, we can go ahead and split it into two problems, one with a positive 12, one with a negative 12. So we'll have x squared plus x equals 12, or x squared plus x equals minus 12. Let's start with the x squared plus x equals 12 side. Since we have a squared term, we know that this is a quadratic equation, and the method to solve quadratics is to get everything on the same side of the equation to put it in standard form. So we'll subtract 12 from both sides of the equation, which gives us x squared plus x minus 12 equals 0. Now we can solve this equation by factoring, so if we factor it out, we'll get x plus 4 times x minus 3 equals 0. Using the zero product property, that means x plus 4 equals 0 or x minus 3 equals 0. So if we solve both of these, we'll get x equals negative 4 or x equals 3. Now let's look at x squared plus x equals minus 12. Again, we want to get everything on the same side of the equation, so we'll add 12 to both sides of the equation, which gives us x squared plus x plus 12 equals 0. Now, this equation we can't factor, so we're going to use the quadratic formula. Our a value is 1, the b value is 1, and the c value is 12. So if we plug those into the quadratic formula, we'll get x equals negative 1 plus or minus the square root of 1 squared minus 4 times 12 times 1 all over 2 times 1. If we simplify, that's going to give us negative 1 plus or minus the square root of negative 47 over 2, which we can rewrite as negative 1 plus or minus the square root of 47 times I all over 2. So our solution is x equals negative 4, x equals 3, or x equals negative 1 plus or minus root 47I all over 2. As a side note, remember the definition of absolute value is the distance a number is from the origin of the number line. Since it's a distance, it can never be negative. So, the absolute value can never be negative. So for example, if you see a problem like the absolute value of 2 minus v equals negative 1, we have the absolute value is equal to a negative number. We know that that can never happen because the absolute value can never be negative. So this equation has no solution because the absolute value cannot be negative. Note that this trick only works once you've isolated the absolute value. So for example, if you have negative 3 times the absolute value of 2 minus x equals negative 4, we can't conclude that there's no solution because we haven't isolated the absolute value yet. But for this problem, there's no solution. Now let's talk about inequalities in absolute value. So similar to the equations with absolute value, the way that you remove the absolute value sign is to split it into two problems. So we'll start with what happens when the absolute value of an expression is less than a number. So if we have the absolute value of u is less than a, that means that u is less than a and u is greater than negative a. So we split the inequality into two problems, one using the exact same expression, u less than a, and when we switch to minus a, we switch the sign of the inequality to give us u is greater than minus a. And the same is true for the less than or equal to sign. So absolute value of u is less than or equal to a means u is less than or equal to a, and u is greater than or equal to minus a. So let's try an example. We have the absolute value of x plus 4 plus 3 is less than 5. Again, remember we want to isolate the absolute value before we try to solve, so let's subtract 3 from both sides of the equation. That gives us the absolute value of x plus 4 is less than 2. So to solve this and remove the absolute value bars, we need to split this into two problems. So we have x plus 4 is greater than negative 2. Notice that when we use the negative value, we switch the inequality from less than to greater than, and x plus 4 is less than 2. So let's solve these. If we start with x plus 4 is greater than negative 2, we can subtract 4 from both sides of the equation, and we get x is greater than negative 6. We move to the positive portion of the problem. If x plus 4 is less than positive 2, we subtract 4 from both sides of the equation, and we get x is less than negative 2. Now we want to combine these two answers into an interval notation. Sometimes the easiest way to do that is to graph both solutions and then use that to identify what our interval should look like. So if x is greater than negative 6, we can draw an open circle at negative 6 and shade to the right. And if x is less than negative 2, we can draw an open circle at negative 2 and shade to the left. So if we look at this, the solution set will be the set where they intersect, where both lines are present. So that's between negative 6 and negative 2. So our solution will be the interval, open parenthesis, negative 6, comma, negative 2, close parenthesis. Let's look at another example. This time we have the absolute value of 3x is less than or equal to 15. I'd like for you to take a few minutes and see if you can solve this inequality and write your solution in interval notation. When you think you have the answer, continue the lecture. Since the absolute value is already isolated, we can go ahead and start by splitting this into two problems. First, we'll have 3x is greater than or equal to negative 15. Again, note that when we use the negative value of the problem, negative 15, the inequality flips sides. Or we could have 3x is less than or equal to positive 15. To solve 3x is greater than or equal to negative 15, we'll divide both sides by 3, and that'll give us x is greater than or equal to negative 5. To solve 3x is less than or equal to 15, we'll divide both sides by 3, and that will give us x is less than or equal to positive 5. Now we want to write this in interval notation. You might be able to do that just from the answers that we have here, but again, sometimes it's easier to sketch the graph. So if we start with x is greater than or equal to negative 5, we would have a closed circle at negative 5 and we would shade to the right. And for x is less than or equal to positive 5, we would have a closed circle at positive 5 and shade to the left. Now the solution will be the set where they overlap, so that will be between negative 5 and positive 5, which are included. So our interval will be square bracket negative 5, comma 5, square bracket. Now let's look at what happens if we have the absolute value is greater than a number. So again, we need to split the absolute value problem into two problems. So if we have the absolute value of u is greater than a, that means that u will be less than negative a, or u is greater than a. So again, the positive value a keeps the same inequality, but when we use the negative a, the inequality changes. Similarly, the absolute value of u is greater than or equal to a implies that u is less than or equal to negative a, or u is greater than or equal to a. So let's do an example. we have the absolute value of 2x is greater than 6. So we can split this into two problems. 2x is less than negative 6. Again, with the negative value, we switch the direction of the inequality, or 2x is greater than positive 6. To solve 2x is less than negative 6, we'll divide both sides by 2, which gives us x is less than negative 3. And to solve 2x is greater than 6, we'll divide both sides by 2, giving us x is greater than 3. Now again, we want to write this in interval notation. A lot of times the easiest way to do that is to sketch the graph. So we start with our number line, and we graph x is less than negative 3. So we have an open circle at negative 3, and we shade to the left. Then we graph x is greater than 3, so there's an open circle at 3, and we shade to the right. Notice when we're dealing with the greater than symbol, an absolute value is greater than a number, we had or in the middle. So for this one, we're not looking for where they intersect, we're just looking for where they exist. So there are two distinct regions. There's a region that's less than negative 3 and the region that's greater than 3. And so we're going to have two intervals combined with a union symbol. So our solution is the interval open parenthesis negative infinity comma negative 3 close parenthesis union open parenthesis 3 comma infinity close parenthesis. Let's look at another example. This time we have the absolute value of 2x minus 3 over 2 plus 1/3 is greater than 1. To start with, we'll remove the absolute value sign by splitting it into two problems. First, we'll have 2x minus 3 over 2 plus 1/3 is less than negative 1. Then we'll have 2x minus 3 over 2 plus 1/3 is greater than positive 1. In order to simplify these, since we have fractions, we want to multiply through by the least common denominator. Since our denominators are 2 and 3, we can find that the least common denominator will be 6. So let's start with the side that has the negative value. We're going to multiply every value by 6. So 6 times 2x minus 3 over 2 plus 6 times 1/3 is less than 6 times negative 1. If we simplify that multiplication, we get 6x minus 9 plus 2 is less than negative 6. Combining like terms on the left-hand side gives us 6x minus 7 is less than negative 6. And now we're ready to start solving for x. We add 7 to both sides of the equation, which gives us 6x is less than 1. We divide both sides by 6 to get x by itself, and that gives us x is less than 1/6. Now we can go through the same process on the positive side. If we multiply everything by the common denominator of 6, we'll get 6 times 2x minus 3 over 2 plus 6 times 1/3 is greater than 6 times 1. Simplifying the multiplication will give us 6x minus 9 plus 2 is greater than 6. We combine like terms on the left-hand side, giving us 6x minus 7 is greater than 6. Add 7 to both sides of the equation, giving us 6x is greater than 13. And finally, we divide both sides by 6 to solve for x, and we get x is greater than 13 over 6. So now we want to take these two values, or these two inequalities, and we want to write an interval that expresses our solution. So we have our solutions: x is less than 1/6 and x is greater than 13 over 6. If we graph those on a number line, x is less than 1/6 will give us a circle, open circle, at 1/6, and the shading to the left, and x is greater than 13 over 6 will give us an open circle at 13 over 6, and shaded to the right. So again, we have a disjoint set here. This is a set that doesn't overlap, so we're going to create an interval that uses two intervals connected with a union sign. So our solution interval will be open parenthesis negative infinity comma 1/6 close parenthesis union with open parenthesis 13 over 6 comma infinity close parenthesis.